So, good morning. I hope you all are well and ready to begin this. So in this tutorial, in this workshop, actually, as I mentioned in my email, we're going to try and learn the basics of Unity. And we're going to build a visualization app, essentially, that can be used as a presentation tool, interactive presentation tool for your Design1 project to showcase the different processes and workflows that you followed. So today we're going to talk about the basics of Unity. There is a few things that you need to be aware of. We're going to start about what is it, what is the anatomy of a Unity project, what are the basic elements that you need to know about, then what is the scene. We talk about how we handle geometry in Unity. We're going to talk about the physics engine that it has embedded, how we do real-time rendering, and then we're going to see how we're building our own app. So we're not going to be doing any coding today because all these things that I mentioned are a handful on themselves, but we're going to start with some C# tomorrow. So what is Unity? It is a cross-platform engine. It was created by Unity Technologies, and we can use it to create both 2D and 3D games, as well as simulations, immersive experiences, and a variety of other applications. It is originally a tool to make games, but it is being used a lot in different other industries like filming, engineering, architecture and construction, you name it. It launched in 2005. It was initially targeting macOS, but then it was extended to Windows and web browsers. And there have been several major versions of Unity. And the latest stable version is Unity 2019.4. That's why I told you to download this one, although there is a newer version, but generally every 2 years they release a new stable version for which they have support and documentation until the next stable version. So it's always safe to use that. Like I said, it's suitable for game development, app development, immersive experiences, simulations, animations, films, etc. And then the supported platforms, which means the devices that you can build Unity apps for. As you can see, it's a long list. Highlighted the ones that you may recognize. It's for mobile phones, of course, for computers, Windows and Mac, WebGL, which is to create web apps, and then a handful of VR and AR devices. So in this diagram, I tried to give a little hint of the different kind of things that you need to have in your mind when you're working in Unity. So the first thing is to have an idea about geometry in space. And what do I mean by that? So Unity handles geometry in a different way than you would do in a modeling software. It's not a modeling software, so it does offer some chances to create geometry, to model it, but it's not like 3ds Max or Blender or Cinema 4D that you actually have this ability. But you need to understand the aspects of the geometry that you bring inside. Usually we import geometry, so you need to understand the aspects of the geometry that you bring inside and where these geometries are in space. And the reason to know that is because then we have real-time behaviors. That means that most of the times these objects are going to be moving in space, or they're going to have some different behaviors, and we need to be able to handle these behaviors by handling the aspects of the geometry. Then we have rendering and graphics, very powerful categories. So Unity is doing real-time rendering. So there is a few different things to be careful off when you're doing real time, because as you can imagine, performance is key. And then graphics, there are different types of graphics, but in this case, I mean, you can create your own user interfaces and things like that. And then we have scripting. So Unity offers a whole range of things that you can do without writing a single line of code. Like you can create already interactive apps without ever doing any coding. But truth is that if you want to build something quite customized to what you need, there are high chances that you're going to have to code it yourself. So the better you become at coding, the more control and power you have over Unity, and you can make it bend ways for you in order to achieve your needs. So we're going to talk now about the basic anatomy of a Unity project. As you can see, we have the toolbar over here on the top. We have over here on the left this window that's called hierarchy window. And basically the hierarchy window is showing all the elements that exist in your current scene. Scene is this one here, sorry, this one over here, D, which is your main workspace if you'd like. C is your game view, which means it shows what you're going to be seeing when this is playing. So it's sort of a render view if you'd like, but when we hit play over here, it will not just give me a still image, it will be running in real time, and based on what we have created, it will have some behaviors, things will move, etc. Over here, we have the inspector window. The inspector window is basically responsible of giving me information. So I can click on items from over here or over here, and it will give me some information about these items. I will explain it when we open it better. And down here, we have the project window, which basically is looking into where this project is created and shows you all the assets that you have loaded inside. So I guess it's better if I explain this with Unity open. And for that, I'm going to open it. So to open it, I hope you all have downloaded Unity Hub. To create a new project, we go over here where it says new. I'm going to click this arrow because I have multiple versions of Unity. So I'm going to make sure that I'm using the one that I told you to download. And then over here, you define what template you want to use with your application. We're going to be using 3D. Over here, you define the project name. So let's name it Unity Session 1. And over here, you define the location that you want this project to be saved. So mine is here. Okay, select folder. So when I hit create, it's going to make the new project. Might take a little bit of time to start up. It's taking a while today, this morning. Well, I only have 3 other Unity projects open, so there you go. Okay. So are you seeing what I'm seeing over here?
Not yet.
Yes.
Should I give it a minute to fire up?
Yeah.
So, like I mentioned, we have our toolbar over here. It has some main things about navigating. So we can use this little hand to do pan. Basically, your scene. So sorry, let me start from the scene. The scene is your workspace, basically. This is where you're going to be doing everything. This is where you have access on things. You can click on them, you can move them, you can do whatever. So there, here's my screen and my scene, sorry. I can zoom in and out with scroll bar. With right click, I can look around. With left click, I can select things, so on and so forth. Then over here in my hierarchy, like I told you, it showcases the objects that you now have in your scene. Every Unity scene comes with a main camera and a directional light. These are the two main objects that you're going to have by default. You see that as I click on them, I get over here in the inspector, like I told you, some information about this object. So I see that it has something that says transform, and then it has something that says camera. And we're going to talk about what these are. But what you keep for now is that when you click on something, you get information about this object. And also, obviously, it gets selected on the scene. And then down here, like I said, in the project, you have your assets, which is basically looking into the project in your directory and everything you will create in that project. So if I go where I created this project, which would be over here, I named this Unity Session 1. You see that if I open it, it has these assets, and over here it has what I'm seeing basically, so my scenes. So whatever I created, it's also going to be created over here. And then we have the console, which I hope you also have it, but it doesn't matter if you don't. So here's where we can print things from when we write our C# code. We can print things and test if things are working properly. And then over here, if you have the second tab, you see it says game. And the game view is basically, like I said, what you're going to be seeing when the app is running. To run the app, we're clicking on this play button. Obviously now nothing's going to happen because we don't have anything on. And I often like to dock the game view next to the scene view so that I can see both of them at the same time. Of course, this works best if you have a large screen or two screens. So yeah, this is the main interface. All good? Yeah.
Yeah.
Okay. So the next thing, I'm gonna talk a little bit about settings. So Unity has a handful of settings that you can change, and sometimes they're very important depending on what you're building. So today I'm just going to show you the main settings tabs so that you know where they are and where you can find them. We're going to start by going to File, Build Settings. So these settings refer to the target platform that your app is going to be made for. You see that it has PC, Mac, and Linux standalone selected. And then you can say which is your target platform and some other things about the code. So this is where you come when you want to build it. And if you want to change, for example, if you want to build for an Android mobile phone, you do it from here, etc., etc. It's sometimes when you already know the platform that you're building for, it is important to have it selected because sometimes it changes things in the app and what it's capable of. And then we have the player settings. We can go directly from here by clicking this, or we could go to Edit, Project Settings, which shows all of the settings for this project. And as you can see, like I said, there are many. So we have audio, graphics, inputs, physics, quality, blah, 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 blah. Player settings are some general settings that are for this app. And you can see it has again a handful. And I guess what we can change for today is we can change over here in player settings where it says other settings. And here where it says color space, we can change it from gamma to linear. So this change essentially changes the color space that our game is going to be rendered. So linear color space provides a more rich color spectrum than gamma, but some devices, some target platforms like mobile phones or some lightweight VR headsets that are not docked to a PC, they can't handle this color space, so you have to go with gamma by default. But for today, we're building a Windows app, so linears should be fine. So I'm going to close this and let's go back here. And finally, we have the assets and asset store. So asset is any item that you can use in your project. And these assets can be created outside of Unity or inside of Unity. And it can be images, videos, audio files, meshes, animations, you name it. Everything that exists in your project is called an asset. So whatever is over here, it's an asset. Whatever you import, you create a material, it's an asset. If you bring in a texture, it's an asset. If you bring in a geometry, it's different assets. Everything is an asset that you bring inside your project. And then we have the asset store, which is a handy little thing that it has been created. And we can find it if we go to Window, Asset Store. And you see that it opened up, it's opening up a new tab, it's connecting to Asset Store. And this basically has some things that other people created and they put them up on the Asset Store so that you can download them and use them in your project. So it might be, I don't know, it can be from, you see dynamic bone, outline of geometries, sky and skyboxes, user interface pack. It can be anything. And sometimes it's paid, other times it's free. Obviously, the good assets are not for free. So you can download these assets and you can import them in your project, and they will bring a number of things. They will bring in scripts, materials, whatever is inherent to this asset, and then you're going to be able to use it without having to recreate it. So that's the asset store. Going back to my scene. Okay, time to talk about the basic elements. So the most basic name that you will hear about Unity is the name game object. And the game object is the most important concept. Everything in your game is a game object. And when I say everything in your game, I mean everything that exists over here. So everything that you have placed over here. So this is a game object, this is a game object, can't change it. So the game objects, they're nothing on their own. They need to be described by a set of properties that define what they are. Like if it's a character, if it's a light, if it's a camera. So define what they are and what they can do. And these properties are called components. And different combinations of them create different kinds of game objects. So over here, you see that, let me talk about component first. So components, like I said, are the functional pieces that make things happen. And the game objects are in essence the containers for the components that will define their behavior. And the most essential component is the transform that all of game objects have by default, because it talks about where this game object exists in space. So where its position, its rotation, and its scale. So obviously, if we didn't have this, the game object would not exist. You can't remove it. And then other than that, Unity provides a wide range of components that you can add to specify the kind of your game object and what it can do. But of course, again, if you want to do some more customized things, you're going to have to write your own components. And this is where C# comes into the game. So basically, you're creating your own behaviors for your game objects, if you like. So going back over here, you see that if I click on the main camera, I do have the transform component, and I do have another component that's called camera, which is basically giving me all the information is basically making it behave as a camera. And over here, I can see all the exposed properties that I can change to affect this behavior. So essentially, this thing is a bit of code script. So you can't open it because it's compiled, but it's a bit of C# code that makes it behave like a camera. Similarly, over here, we have a transform and we have a light component. This component makes it be a light. Does that make sense?
Yeah.
Yeah.
So they don't come, the game objects can come predefined with their own components, and you can also create empty ones and fill them with your own. And to create a new game object, let's create an empty one and a base geometry one. So you can either go over here where it says game object, and you see you can create empty 3D object, 2D object, blah, blah, blah. So, or you can over here in your hierarchy, you can right click and you can create. So I'm going to create an empty game object, and you see that all it has is a transform. Like we said, it can't exist without it. And then we can create also a cube. And you can see that the cube is just basic geometry. And over here, apart from the transform, I have 3 other components: the mesh filter, the mesh renderer, and the box collider. And we're going to talk about all of these components in a little bit. Another thing I wanted to mention is that you see over here, it has a drop down, so a field that's named tag, another one that's named layer. So layers in Unity are not, well, you don't see the layer structure as you would see it in Rhino. So you don't exactly work with layers in the same way, but the layers can help you differentiate the different game objects. And this can be useful to select that, oh, for this layer, this behavior is going to work, whereas for this other layer, this behavior is not going to work. Because sometimes we might have some global behaviors that are not affecting specifically one game object. We're going to see about that. But in the layer tab, you see that if I click on this drop down, I have the default layers that Unity has. And if I want to add my own, I click add layer. You see all of these places are grayed out because they're the default ones from Unity, but I can add whatever over here. So let's name it, what's the layer that we're going to use today? Ground. Let's name it ground. And let's name another one that's called post-processing. So now I created these layers. If I click away from this one, so go back to my game object, you see that if I click now on the drop down, I have these layers as well, and I can change my object to those. Okay, so this is the basic of the game object. And finally, another thing to know is that when you have configured and customized the game object and added all of the components that you wanted to have, Unity gives you the opportunity to store this particular game object as an asset. So that means that it's not going to exist only here, but it will also exist in your directory as an asset that you're going to be able to reuse. And this kind of asset has a specific name. It's called the prefab. And prefabs are very useful because they allow you to easily generate numerous instances of the same object, but at the same time, all of these instances hold a reference to the original prefab, but at the same time, you can customize all of the exposed properties that the components have. I guess the concept of prefabs is going to become more clear when we use a few of them. But to create your own prefab, you would come you would drag and drop basically the component into your project. So I'm going to create a new folder because I very much like to have things tidy. So to create a new folder over here in my project, in the assets, I right click, create folder, going to name it prefabs. And then I open this folder, and let's say that I wanted to make this cube as a prefab. I'm going to drag and drop it in here. And now it's going to be over here. And you see that it also turned blue. And this means that this is a prefab. And it also has this arrow over here, which says that open the prefab. And if I go here, it gives me an isolated view. And basically I can add and remove components to this prefab, make it to whatever, and the asset will be updated. And also all of the instances that I have created of this prefab are going to be updated. To add a new instance in my game, I drag and drop the other way. So here's my prefab. If I drag and drop it in here, I have another instance of the cube, another instance, etc., etc. And if I change inside here, all of these instances are going to change. Does that make sense?
How did you add the box into the assets? Into the
So you drag and drop this over here, the cube basically. You drag it and you drop it inside the assets.
Yes.
Okay. So the next step is to talk about Unity scene. So like we mentioned before, the scene is your workspace, and in game words, it represents somewhat of a level of your game. I'm going to explain what that means, and we're actually going to see it in the app that we're going to build, because we're going to have a lot of different scenes. But essentially, the scene contains all the elements that define your project, like what are the game objects, the UI elements, the special effects, you name it. Like I said, a project can contain many scenes. You can only have one active scene at a time. That means, of course, you can have one active workspace. And like we said, every scene has by default a camera and a light. And these are the essential elements to get started. So camera. The camera is the game object that is responsible for what the player sees in the app. You need at least one active camera game object on your scene, but you're not limited to have just the one. So over here, you see that I have my camera over here, and it shows me in the game view. That's why I have them side by side, because I like to see what my camera sees. You see, it shows me what it sees. If I zoom in and out, click on my camera. If you click out and the left click, you have more of a controlled rotating and zooming in, because basically it uses your mouse as a focus point for the panning and the zooming and the rotating. So you see that I have my camera, and it shows me the spectrum that this camera is looking at. So you see that it's looking at my objects. It is and it's not in this field of view. So if I move my camera, obviously you see that I have a gizmo over here. So to move it, I can either move the gizmo, or I can go over here in the transform tab, and I can actually type the position that I want. So let's say that I want it to be at 3, 2, that's fine. So I can change it from here. Obviously the same goes for the rotation. This is the fun time that we talk about how Unity has the y-axis up and the z-axis on the horizontal plane, which is great when you bring things from Rhino. So obviously if I want to rotate something around the y, I can do it like that. To do this dragging, you see that if I hover over the y, it gives me this double arrow thing. So if I click now and I just drag, it will rotate. So this is another nifty trick. Or again, you can type like the degrees, etc. And obviously the scale. Let's not use the scale for the camera. Okay, so this is the transform. Over here, Over here on the top, you see that I have clicked this move tool. I can also click the rotate tool. So it will give me the option to rotate it in the 3 axes. And then there is the scale tool, scale it. Obviously, let's not do it for the camera. And this is the rectangle tool. We're going to use it more for the UI elements that we're going to be making in another session. Let's go back to the transform. And let's talk about this camera component. So the camera component, it's basically over here. It tells me clear flags. It's what's going to show on the background. So by default, it has this item that's called the skybox, and it's this poor quality sort of sky that you see over here is Unity's default. You don't have to use it. You can use the solid color, which basically is this color over here. You can change it, and it can be whatever. And then the culling mask is basically what this camera renders. So you see that here are the layers that we saw before, and they have a check mark next to everything. If I uncheck one of these, it means that the camera won't render the objects in this layer. So let's go and place my cube in the ground layer. I can't do it from here because it's a prefab, so I have to go inside the prefab. And then over here in the prefab tab, I can go where it says layer, place it to ground, and you see automatically I lost it because the camera is no longer rendering things that are in this layer. Going outside, going back to my camera. Let's change it back so that you can see it. So this is a neat trick of making the camera see and not see different objects. And that can allow you to have more than one cameras looking at the same scene, but seeing different things. And this helps with some rendering things and layering things on top of each other. That we're not going to talk about today. And then other components are the projection, which can be perspective or it can be orthographic. So you see that orthographic is orthographic and perspective has the angles. And then you can affect the field of view. And the clipping planes. So the clipping planes are what it says basically. You see that this camera has a range. This preview of the gizmo of the camera of the field of view, and I can affect it. So if, for example, I make this 10, you see how close this camera renders. It's still enough for my cube, but if my cube moves outside of this plane, I automatically lose it. So sometimes we have this annoying thing that the camera cannot see far enough, especially if your scene has like landscapes, like large models. And you're like, but I can't see far enough. It can be the clipping planes. And some other things that we don't have to talk about at this point. Let's not get into too much detail. The next thing is the lights. So obviously, in order to calculate the shading of any game object, Unity needs to know the intensity of the light, the direction of the light, the color of the light, etc. There is a variety of light game objects available in Unity that we'll explain later when we talk about the rendering things. The default light that is created, as you saw, it's called the directional light. And the directional light represents basically, is kind of like a sun. It represents a distant light source that comes from a position outside of the range of the game world, and it basically all it has is a direction. So you don't see a halo, you don't see the light itself. If you move it, it will not change anything in the shading. So let's go to this directional light. So you see that if I move it, nothing changes. But if you click on the object, but if you double click on the objects, it focuses on it. Okay, so if I change the rotation, you see how the shading changes on the object. So it doesn't matter if I move it because it's an infinite light source, but if I rotate it, it changes the direction, so it changes the shading of this object. We're good so far?
Yeah.
Okay, so time to talk about geometry then. So the main graphics primitive that Unity uses in order to render geometry is the mesh. You know a little bit about meshes, I guess. So you know what it is. You know that it's the collection of vertices, edges, and faces that make up a 3D object. And you know that its vertex stores the X, Y, and Z coordinate information. The face of the polygon, say, stores the order of vertices that need to be connected. And then the polygon meshes also contain other types of information like the UVs, the colors, and things like that. So Unity doesn't take any NURBS geometries. So if you're exporting things from Rhino, you need to export in a specific kind of format so that you can bring it inside Unity. And then the basic components that you absolutely need in order to see any mesh geometry are called the mesh filter and the mesh renderer. The mesh filter is basically responsible for holding the mesh data. So all of these vertex information and index information and face information are handled in the mesh filter component for you. And the mesh renderer is responsible for taking this information and making it appear on your screen. So for rendering the object. And if we go in our scene over here, like we said before, you see over here in the cube that by default, it has a mesh renderer and a mesh filter. Let's close it. Give me a moment. Okay, a mesh renderer and a mesh filter. You see that the mesh filter, you don't actually have anything exposed to affect, but the mesh renderer, you see that if I unclick it, I basically don't see the cube anymore because this is responsible for showing it on my screen, for rendering the object. The cube here over here in the mesh filter, it still exists. So if where does it appear? If I double click, it actually takes me to the mesh. This is the mesh. You see the faces, the vertices, etc. So this is the information for this mesh. But the mesh renderer is what displays it. So here's also where we add, as you see, the material for this object, which we're going to talk about in a little bit. All clear about the mesh situation?
How do you go back from when you got double click to see the mesh?
I just clicked outside, so I clicked the cube again. Okay, so we talked about we need to export things from Rhino in a specific way, and then we want to import them into Unity. And this means that we have, basically when we're importing geometries, depending on their format, Unity automatically creates an asset that holds the necessary information, like mesh, materials, colors, whatever the format includes. And it also creates a prefab out of it. So when you import something, it will exist in your assets folder, and it will also be below. It means it's going to be a prefab. And you have the opportunity to change some of the geometry properties when importing it through the import settings window that we're going to see in a little bit. I forgot to share this with you, but I created this folder. Let me just share the link. Okay. For Zoom. So if you go over here, there is this folder that's called Day One Resources, and it would be great if you could download it. Shouldn't take much time. because inside here it has some things that we're going to be using today. So it's this one over here, this folder. I'm also going to download it so that we're on the same page. Okay. So if I go here in my downloads, I'm going to extract. And I should have it. Let me know when you have it. I don't know if you downloaded it, if it takes time.
Got it.
Okay. So you see over here that it has 3 images, 1 script, 1 HDRI image, and 2 geometries. So the geometries are FBX, I think. FBX, yes. So are you all aware with OBJ and FBX formats, file formats? Should I speak a little bit about those?
Yeah, I think I only know OBJ.
Okay, so OBJ is basically, it's a simple format of saving 3D models, and it can hold information like meshes and vertices and UVs and things like that. It's a text file. So the good thing about the OBJs is that you can open and look at the information. And then the FBX file is a more complex way of saving 3D geometry. And it's a binary file, so you cannot look inside it. I mean, you cannot open it with a notepad and look what's going on. And it holds information apart from the meshes for a lot of other more complicated things, which can be lights, animations, 3D rigs, and things like that. So it's a more complicated file. And when we're exporting from Rhino, you can export as OBJ or FBX, and you bring it inside Unity. From other 3D software like 3ds Max and Cinema 4D, Maya and Blender, I think you can also bring the native file inside Unity as it is. I'm not sure about all of them. Okay, so for our first try, I'm going to bring inside this test 3D. So I'm going to create over here another folder, create folder. I'm going to name it 3D models. Open it, and inside this 3D models folder, I can drag and drop this test 3D. And as you can see over here, like I said, it's going to make an asset out of it, and it has the information about the mesh, the material, and over here it has exported the viewports of Rhino. I don't know why it has though. Anyway, so we're going to drag and drop it inside our scene. So you can either drop it here or here, doesn't really matter. And you see that it has a bunch of stuff going on over here. Create all this noise. This is because it also has the front, perspective, right, and top. So it has all these different things that I don't need from Rhino. So I can delete those. I can right click and do unpack prefab. And this will take care of, this will basically not have this as a prefab anymore in the scene. Because otherwise, if I go to delete this, it tells me that children of a prefab instance cannot be deleted or moved, blah, blah, blah. You can unpack the prefab if you want. So let's go ahead and do that. Unpack prefab. And now you see that it's not blue anymore. So I can take We can get rid of all these. And over here is actually my geometry, which is what I need. So I'm going to take it out. So it's not nested over here. These are empty. I can just delete those. So this is what I need. You see that by default, it is rotated 90 degrees. So I don't want that. This is something that comes by default from Rhino. Don't know why. And I can see that it's extremely tiny. Now is the time to talk about scale. So going back to my geometry over here in the assets, if I click on it, you see that I have the test 3D import settings. And you see that I have different types of import tabs. I have the model, the rig, the animation, and the materials. Right now, we don't care about these three, but we do care about the model. And the first thing that we care about is over here where it says scale. So the scale factor over here is 1. That the scale factor means that whatever it's bringing in, it's going to uniformly scale it by something. So I can affect that.
Eliana, where did you enter the import settings?
You just click over here.
Okay, okay.
On that. Convert units. So what this does is it basically, Unity has no unit system. I mean, not like Rhino has, where you can change the units and take them from meters to millimeters to centimeters to inches, whatever. What it has its own inherent system. And basically, when you see over here in the scale, it says 1, that means 1 unit. So what it does here, it's trying to convert the units of your file to the equivalent Unity thing. And the reason we need that is so that the physics engine is going to work well. I'm going to talk about physics in just a minute. Then there are some other things over here. So it says import visibility, import cameras. So I'm guessing that these are the things that didn't come inside. Import light, I don't want any of these. And then these are some information about the meshes. And the only thing that we want from the meshes is to generate colliders. And I'm going to tell you in a minute about that. And then some other things about the meshes. And when we're done with doing the settings, we hit apply. So when we do that, if I drag and drop this in, well, now at least it's better. You see that it still has those. Oh, well. Anyway, it doesn't have the camera though, and all the other things. Let's try and creating, sorry.
Eliana, when I drag the object onto the scene, it doesn't show in blue. It just gives it to me like as a clone.
What do you mean in blue? Or like this?
Yeah, the test 3D, it just shows as a clone with no, with no arrow.
It doesn't have an arrow over here.
No, I mean, it's not in blue.
Oh, okay, that's weird. So you dragged it from over here and it's just not blue.
Yeah.
Interesting. Okay, but let's try this. So we're going to change the scale and let me know if this updates. So let's say make it 10 and hit apply. So now mine got 10 times bigger. And let's make it a lot more. So does it change for you, George?
No, nothing.
Interesting. Okay.
Like
so
the object shows, but there's...
Okay. Do you get anything in the console over here? Do you have any reds?
No.
Messages?
No.
Interesting bug with prefabs. Okay, it doesn't matter. You can change the scale factor as well from over here. So you don't have to worry. Okay, so you see that this object was affected as well, because although it's not anymore a prefab, it's still coming from the same import settings. So I think that's fine for what we want. I'm just going to take this out. This is the previous object that we had. And let's create also a plane, so like a ground. So I'm going to right click over here. I'm going to go to 3D object, plane. And you see that I have this weird thing standing over here over my plane. And the reason I want to create this configuration is because I want to give you a look into the physics engine that Unity has. So is it all clear with importing things? I want to hope so.
Yes, it is. It's just that my plane is, like my object is below my plane.
Okay.
I think it's just the position.
Yeah, so my object is at 0, 0, 0. Is yours there?
No. Yeah, okay.
So you can do that. Or you can move the plane. It doesn't have to be.
I have some kind of red error.
Sorry?
I have an error, failed copying the file, and it shows the address.
Fail to what?
Copying the file.
Okay.
Unity editor.
Yeah, sometimes Unity throws some bugs that you don't need to care about. You can just click clear over here. Does it go away if you hit clear?
Yes.
Okay, if it goes away, that's a good thing. If it's a real bug, it just stay there and not let you do anything. Okay, so next thing we're going to talk about physics. So Unity, like many game engines, comes with its own inherent physics engine. And the physics engine is responsible for simulating all the motions and reactions of objects as if they existed in an environment of real-world physics. So in other words, these kind of engines, they provide approximations of certain physical systems and physical phenomena as they would work in real world. And these systems can be more basic, like rigid bodies and soft bodies, and it can also be more complex, like fluid dynamics and things like that. So the Unity physics has a lot of components that you can play with, and you can do a lot of things. Today we're going to talk about the rigid bodies and the colliders. So the rigid body is the main component that it's basically enabling the physical behavior. So it's like when you add this component, you're telling to Unity that this game object is going to have physics, it's going to react with physics. And by default, when you attach the rigid body, the object will automatically respond to gravity, to a gravity force. So that's why I said, remember in the import settings that when we convert the over here, this convert units, it's basically converting our model to a format that will work well with physics, so that it would respond to gravity in a realistic kind of way, in a realistic kind of scale. And then we have the colliders. The collider component defines the shape of the game object for the purpose of physical collisions. So the collider is invisible and it doesn't need to match the exact shape as the game object mesh. And we're going to see a little bit how this to work. Okay, so first of all, we have our little cube over here. And let me move my camera so what we're seeing actually makes some sense. So take it over here, and I'm going to rotate it 90 degrees. Okay, I'm going to also change the direction of the light so that I'm actually not seeing the darker side of the objects. Okay, so let's go to our cube. And I'm going to unpack the prefab now because I don't want this to work as a prefab anymore. I don't want to go inside every time I need to change something. So I'm going to unpack prefab. And it's a normal cube again. You see that it already has a box collider. And we're going to also add the component that's called rigid body. So to add the component, we go here, add component, and you can search for the component. So we're going to add the rigid body. If I start typing, it should pop up. So rigid body, I click on it. And you see that it has some properties of the physical body. So like the mass, what is the drag? You see that by default, it has use gravity. So what happens if I hit play? Play means that I'm going to start the application. And it just fell down because gravity took action. Whereas you see that this game object that has no rigid body, it just stayed, didn't react to anything. So the rigid body is what makes physics affect this game object, and the box collider is responsible for the collision. If I turn off the mesh renderer for a moment, and I go over here in my object, you see this green outline? So this is the shape of the collider. I can affect the collider's scale. So let's say that I want to make it 2 by 2. And if I turn on the mesh render, you see that my object hasn't actually changed, but my collider has. So if I click on play again, actually the collision is, now it looks like it's floating. It's only because the collider body is larger. Does that make sense on the colliders?
Yeah.
Cool. Let me turn it back to normal. So the colliders are these kind of components that define this collision. There are different primitives. There's a box collider, a sphere collider, etc. Basically for all the basic geometries of Unity. And then when you import one of your own geometries, it actually comes. It doesn't come. Ah, yes, it doesn't come because when I went over here, I clicked generate collide. Give me a moment. Okay, so because I had this object from before, it didn't generate the colliders. So I'm just gonna quickly redo it. So you see in the import settings, when we click generate colliders, I didn't have this from the start. And when I actually imported them with the generate colliders, it created a mesh collider. Whereas when I imported it without clicking that, it doesn't have any collider. So I'm just gonna quickly unpack the prefab again, grab this, delete those, and just use this game object with the mesh collider. And I need to also click there. So if I unclick on the mesh render, you see how my collider is over here. So it's trying to follow the mesh geometry. I'm going to add a rigid body to this one as well. So rigid body. And I'm pretty sure it's going to tell me if I click over here. It fell through, and that is because it gave me this error over here. It says non-convex mesh collider with non-kinematic rigid bodies no longer supported in Unity. So I come over here where it says mesh collider, and I'm actually going to click on convex. So convex is basically creating a convex shape around your object, and it uses this as the collider. So because it's testing collisions, it doesn't want to deal with just a mesh collider, which is so detailed. It's trying to follow all of the faces of your mesh, and you can bring in some pretty complicated meshes. So Unity as a policy has decided that for collisions, I'm just going to use the convex, a simplified convex geometry that includes your geometry. I'm going to clear this error, and now that my collider is convex, if I hit play, you see how this fell down as well. And then we can do some interesting things with the collider. You see that it has over here a material, and it says physics, it says that it takes physics material. It says none because it doesn't have anything at the moment, but we can create our own physics materials. So maybe I can come over here, create a new folder. Let's name it materials. And inside here, I can right click and go to create. Where are you? Physics material. Let's name it material 1. And you see over here, it has some properties about the friction of your object and the bounciness. So let's make it bouncy. Let's make this to 2. It can go higher than 1. Good. And leave those as they are. And if I come back to my object and I can assign this material over here, as I can assign to any of the input fields in 2 different ways. The first way is if I grab the material and drag and drop it over here. The second way is if I click on this circle over here, it will basically open a menu for me that will list all of the available things that I can put in this field. So it basically only has that because this is the only physics material that we have. So I'm going to click on it, and now it has my material. And if I play this again, now it should be bouncy. You see how it became a little bouncy when it fell. All clear?
Yes.
Okay. Cool. Then there are a lot of other things that you can do with physics. Just to make you aware of that, it has a handful of hinge components. Joint components. So if I do joint, you see that it has fixed joint, hinge joint, spring joint, etc. You can do a number of easy physics with these kind of joints, but I'm not going to get into it today because we're running a little bit late in our schedule. So that's it with the basic physics for now. And let's move on to rendering because this is a big chapter. Obviously, we're not going to go into too much detail into creating like the perfect visualization in Unity, but at the same time, I want you to have a grasp of the basics and also know a few tricks that can make things look pretty fast. Okay, so rendering, blah, 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 is an automated process that enables us to see things in our game. Basically, what happens when you render is your computer graphics converts 3D models into 2D images with the effects that you have created. And as you know, if you've rendered anything, it can take from seconds to days for a single image. Now, in Unity, we have real-time rendering in most cases. So that means that all of the light calculations that take time to do for a still image, they're happening in real time. And what you're seeing is basically Unity rendering images so fast that it looks like it's a real-time thing. It's like a video, if you'd like. So as you can imagine, when we're talking about real time, there are some differences in the rendering and there are some things to be considered. And also there are some, limitations. There are some limitations in the things that you can do and the things that you can see. For example, reflections, shadows, and all of these things, they are in a certain extent affected by the real-time thing, and you can't make it as realistic as you would do in 3ds Max or whatever. It's getting more and it's evolving more and more together with the evolution of graphics cards and the computational power of computers. And it has come a long way, but it's still not, you know, a renderer the same as you would render a still image in Maya, for example. Okay, so rendering basics. like we said, the meshes are the graphics primitives that Unity uses. And then in order to be able to see any kind of mesh, we need two key things. We need lights, light sources, and we need materials. And lights are the components that define how light particles interact with your geometry. And then materials are the components that define how your geometry will behave when it's hit by one or more light sources. Quickly to talk about lights, Unity, like we said, offers a few options. We have the point light, you can see over here. This is basically a single source, and the how's it called? The range has this spherical type of expansion. And you can affect obviously how big this range is, how bright the light is, the color of the light, etc. Spotlight is similar to the directional light in a way, but you moving its position, it affects what happens with the light. It has a conic range. Again, you can affect the characteristics of this range, color, brightness, etc. Then we have the directional light that we saw it before. It's like a sun, as we mentioned. And then we have the area lights. And the area light is basically like having a surface that is emitting light from all over. So the area light is actually only working in baked lighting. And this is the time to talk about real-time and baked lighting. So Unity, as we said, is doing real-time rendering, and this sometimes can be heavy for your game. And there are some tricks to save this. And one of them is to bake some lights. So essentially, if you know that some objects in your scene are never going to move, you don't actually need to calculate the lights again and again and again for these things. But you can calculate them once and bake them. And baking them actually creates sort of a stencil on top of their actual textures, which is the light, so basically the shadows. And this is a very good method of managing the performance of your game. So area light is by default baked, and all of the other lights can give you the option to have them real-time or baked. And then there are the shaders and the materials. So shaders are basically small scripts that are written in a different language than C#, than shader language, and they contain basically the mathematical calculations and algorithms that calculate the color of each pixel that is rendered on your screen. So it's basically the bit of code that tells to your computer, show this on the screen. And the shaders are, you can see, are defining basically the material's behavior. So if I go to Unity over here, let's create a new material. So if I right click, I'm gonna hit create material this time, not physical material. And let's name it basic. And you see over here, the material, the first thing that I have to select is the shader. So by default, it has standard. And there are numerous shaders that Unity has. Of course, we're not going to look now at all of them. The standard is the most, the one that has the most options, but obviously, when you become more and more advanced, you can reach a level that you can write your own shaders and you can make the materials behave in the ways that you want. So now we have the standard, we're going to leave it at that. And over here you have the rendering mode. So if you want transparent or opaque or cutout objects, and then you have very usual options in the material. So you have the albedo, which is the color of your material. Let's make it red. You have the smoothness. So the metallic and the smoothness are basically affecting the reflectivity and glossiness of your material. So the smoothness, it's defining if your object, as you can see here in the preview, is reflective, more or less reflective. And the metallic is saying basically how much the color is being taken into consideration into this reflection. So the higher I take the metallic, this will become darker. And then we have the normal map, height map, occlusion, detail, mask. Over here, you see, you can click again on these little circles, and this is where you can introduce textures for these ones. So you can have a texture for the smoothness, a texture for the normal, a texture for the occlusion. I'm sure if you've done a little bit of rendering, you have an idea about those. If you don't, that's okay. So let's assign this material to our object. In order to do that, again, I can do this in two ways. I can either drag it from over here and drop it on the object directly, or I can go over here in the material, and remember that we said that the mesh renderer is responsible for rendering, and over here it has a material. So if I click on the circle, click over here, it will get the material. All good?
Yes.
Okay. And the final thing about rendering is the post-processing effects. So this is an extra package that we import into Unity. And it's basically applying some full screen filters that affect directly your camera. And it can drastically improve how things look. And kind of works a little bit like Instagram, if you'd like. You have all these effects there, camera effects. Like you have ambient occlusion, chromatic aberration, grading, fog, exposure, grain, motion blur, vignette. It's a neat trick, and we're going to use it in a little bit, and you're going to see how good it can look. Is it all clear?
Yes.
Okay, so we're now going to make a scene. We're going to make a small little app that is basically, we're going to import the geometry that you created with Milad for the previous tutorials, and we're going to make it very nice with materials and the sky and the lights. And we're also going to add a character that's going to navigate, walk basically in the scene and look things around. So we're going to create a new scene. And in order to do that, we're going to come over here. First of all, this scene is the sample scene. And how can I know that? If I come over here on the top, you see that it says Unity Session 1. This is the name of my project. Sample scene. This is the name of the scene. PC, Mac, and Linux standalone. This is the target platform that this is building for. And finally, the version of Unity that you're using for this project. So now I have this sample scene over here. I will first of all save this, and then I'm going to create a new scene. So I'm going to come to File, New Scene. So you see I have an empty one, but if I go over here to Scenes, I still have my sample scene saved. And let's save our new scene as something. So I'm going to go to File, Save As, and let's name it. Sorry, I'm going to place it inside the scene so that they're all together. I'm going to name it, yes.
It's giving me that I can start a new scene before exiting play mode.
Oh yeah, so you haven't stopped. You need to click on the play again.
Yeah.
So yeah, that is something that happens a lot when you start with Unity. You hit play and you forget to click it to stop it. This one, the pause button, it just pauses it. It doesn't stop it. If you want to stop it, you need to click play again. Sorry, we haven't done much dynamic stuff yet, and I forgot to mention this. So also when you're in play mode and you change things, for example, you might add something to a component, change something to a component. If you stop it, everything that you change will be lost. So check twice if you've stopped the game when you're doing changes. Okay.
So how do I save my changes before?
Which changes?
Like I stopped the game because I had this error, and now I don't see the the geometries?
Did you create them when you were in the game mode?
Yes.
They're lost.
Okay.
Sorry.
So next time,
You
how
can't save them. What you can do is sometimes you can save some components. For example, let's say over here in the play mode, and well, I'm gonna go back to the previous scene that we have some objects. So I'm over here, I'm playing. Come on. I'm playing. And here's my camera. Here's what I'm seeing. I can move the camera and rotate it if you like. Whatever, affect the transform. And then what I can do before stopping it to change this position is I can come here to the transform component, right click on it and do copy component. And then if I stop it, it will go back, but I can come again over here and I can do paste component values and it will keep the ones that I had in the game. But that's as much saving as you can do. Like you can save one component state.
So everything should be edited not in play mode.
Sorry?
So everything should be added not in play mode.
Yes, yes. Okay, so I guess I lost my other scene, so I'm just gonna create it again, new scene. And let's save this new scene. So to save it, I'm gonna go to file again, I'm going to save as, and I'm gonna go into scenes, and I'm going to name it design one walkthrough. So now you see the name of the scene over here, you see the name of the scene over here, it's all good. And also you see that in my scenes folder, I have now two scenes that I can switch between. So one workspace, another workspace, and I can have multiple. Okay, so the next thing that we're going to do is we're gonna go back to our day one resources and we're gonna bring a few things in. So first of all, in the 3D models, we're going to bring inside the other 3D, the test aggregation meters. So I'm going to drag and drop it in here. It's kind of a heavy file, so it might take a minute to load it. Okay, so we have our 3D model. Then I'm going to go back to my main assets folder, and I'm going to create another folder that's going to be called textures. So folder, this is called textures. And over here in the textures, I'm gonna go and I'm going to import these three things, drag and drop them in here.
Which file did you put in the 3D models? Which one?
I put it in the 3D model one, the one that we created before, that also has the other geometry. It's not wildly important, but I like to keep things tidy because it can get messy. Where was that? Yes, in the textures, we imported these three textures. And we're also going to import this one, the HDRI. So I'm going to drag and drop it in here. It's inside. So we have 4 textures. And then after we import these, I'm going to go and create the last folder. I'm going to name it scripts. Like I said, we're not going to do any scripting today, but I have created a component that we're going to use for our character movement, and we can look into it another time. So I'm going to just drag and drop this over here. Should appear like that with the hashtag. And we're done with importing things. Is it all good?
Yeah.
Okay, so first things first, let's bring in our 3D model. So grabbing this one over here, I'm sure it looks familiar. I'm dropping it inside. As you can see, it has no wires. And that is because in the Rhino model, these were lines and line is not a mesh, and it also doesn't get meshed when you export as OBJ. So if you want to actually bring in the wires in your models, you're going to have to pipe them or something like that, and then it will create meshes out of it. But I didn't at this point because I didn't want to have a very heavy file to begin with. So this is our basic geometry. Let's also add a ground. So I'm going to right click. I'm going to create a plane. I'm going to put the plane in 0, 0, 0.
Ileana, do we have to do the generate colliders before?
Well, we're not going to do any physics, so you can leave it like that. Actually,
Okay.
you know what? Yeah, let's do it so that the character is not going to pass through our object. So generate colliders and apply. We don't have to change anything in the over here. I think it should have imported collider. Yeah, so it has colliders. All good. What's next? And I guess we can create our character. So we're going to just create a very simple one. We're going to create a capsule. Go 3D object, capsule, which is this pretty thing. Let's place it in 0, 0, 0 again. Actually 0, 1, 0, so that it's on the ground. And I'm going to take this over here. It's a bit large, so let's make it a little thinner. So let's make it 0 0.7, 0 0.7, and maybe okay. So this is our character. This is the object that's going to move around and explore this space. Actually, let's also make our ground plane a little larger. I can rename these so they make more sense. So if I come here on the plane and I right click and I do rename, I can change it to ground plane. And also this capsule, I can rename it to player. Okay, and like I said, let's make the ground plane larger. So let's make it like 5, 5, 5. That's large enough. It's huge. Okay, and going back to our player, we're going to create. We're going to add 2 components basically. The first thing that we're going to do is we're going to take away the capsule collider. We're going to delete it because we're going to add a similar component that is for characters. So I'm going to right click over here and I'm going to remove this component. And then we're going to add component and we're going to add a character controller. So if I start typing it, it comes up over here, character controller. Let me
Where did you add it? From where?
You just click add component and you type it. So anytime you want to add a component, you click here and you type the component that you're looking for. If you type a name that doesn't exist, it's going to understand that you're going to write your own component, so it will automatically create a C# script for you.
Okay.
Okay, so let me just check a little bit. Yeah, that looks about right. Okay, so together with the character controller, we're going to add the script that I gave to you with the resources. So we're going to add, and you see it's called my character controller. So I'm going to click on it. And this one, what it does is you see that there are some things that are exposed over here. It requires for a camera, it requires for a ground check. This is the ground. It's asking you if you want to use gravity, and then these are some sensitivities for the mouse. So basically what this script will do is it will allow you to move your character by using the arrow keys on the front and back arrow keys on your computer. And also it will make the view rotate with the movement of your mouse. So let's go and add the camera. So we're going to drag the main camera and drop it in here where it says camera. Then for the ground, we're going to grab the plane and we're going to drop it over here where it says plane. We want to make sure that we have our plane in the ground layer. So I'm going to go over there in the plane. I'm going to change it to ground. And I was here in the player. And I want to use gravity. Yes, I want to use it. And for the ground mask is the layer basically that the ground exists. And I can say that this is the ground. So I have all things configured over here. And if I click play, let's see what's going to happen. Okay. So you see that with the movement of my mouse, I can basically move the view. And if you click on the arrows, it's moving back and forth, or basically front, back, left, right. But this is not exactly what we need. What we need, so you're not gonna be able to see your mouse. In order to see your mouse and stop the game, you can click on escape, and then it's going to show, and you're gonna click on play again, it will stop. What I actually wanted was to create a first-person controller. So that means that I actually want my camera to be mounted on the head of this thing. So in order to do that, I'm going to explore this concept in Unity that's called parenting. So basically, when I have an object, a game object, and when you see the game object being nested, that means that the first game object is called the parent and the other ones are the children. So let's say that by having this clicked, I create another cube, let's say. And if I go over here to the cube and I move it, I can do whatever I want to the cube. But if I come here on the player and I move the player, now they move together. So that means that they have this constraint. This one is called the parent and this one is called the child. And obviously you can have infinite nesting, and each of the children is going to be nested to the parent and the other parent and the other parent. What's interesting about this is that the position that the cube shows over here is not the real world position. It's actually the local position based on the parent. So if I click 0 and 0, it will basically go wherever the parent is. Does that make sense? Okay.
Yeah.
So what we will actually do is we're going to make the camera a child of our player. So I'm going to delete this cube over here. In order to make it a child, I'm going to just drop it onto the player and it will automatically become a child. Now my camera, as you can see, is not aligned with the player. So I'm going to place it to 0 and 0. And now it's on the player. And actually, I just want to make sure that it's a little bit higher. So it's in the head and the eyes level. So let's take it with the hand or from over here. It's your call. Let's take it a bit higher. Player, camera. And now we can rotate our player. Sorry. Can rotate this little guy. And we can also move it as a starting point. So we're starting from here. And let's see if we play now, what will happen. So now if we play, we can actually look around with our mouse, and we can also move around our beautiful thing that we have created here. If I click escape again, I can stop the game. Does that make sense? Is it all good?
That's so nice.
Sorry?
That's so nice.
Yeah. Okay, so now it's time to make it pretty before we build it. So the first thing that we want to do is we want to change this boring skybox that we have. I'm gonna make this in view. So this boring basic generic Unity skybox, we want to change it to one of our own. We already imported over here in the textures this HDR image, and we're going to use it as our sky. But first, we need to change some things in the import settings. Remember, see that the textures also have import settings like we saw in the geometries. And what we want to change over here is where it says the texture, yes, the texture shape, we want to change it into a cube. And we're just going to hit apply. And this will make it into this sphere over here. It understands that it is an HDRI image. And then we want to create a material with this image. So we're going to go back to our materials. I'm going to create material. We're going to name it my skybox. I'm sorry, I'm bad at naming this morning. My skybox. And let me quickly check. Yeah, so first thing we're going to do is we're going to change the shader. So we're going to change it from standard to skybox, you see over here, and then cube map. So this is the type of material that is used for the skyboxes. This type of skyboxes that you import an HDR image. So over here, you see that it has a field that is expecting an HDR image. So we can, similar way, we can either click over here and select and find our image, or we could have dragged and dropped it. And okay, so we created the material, but we don't yet see it in our scene. So in order to see it, we need to go to another tab, another nice tab that's called lighting settings. And in order more settings, in order to find that, we go to window, rendering, lighting settings. And it's gonna pop up this tab. I like to keep it docked because I revisit it a lot. So I'm gonna just dock it over here next to the inspector, right here. And you see over here in the lighting settings, it says skybox material, default skybox. So I'm gonna click on this little circle here, and I'm going to locate it, the material it has created, and I'm going to change it to that. So now instead of having this boring Unity skybox, I have my own one. I'm going to change the aspect ratio over here to 16:9 because I like, basically we had it to free aspect. So it changes every time I move it. I prefer to see a fixed ratio. You see that it has some default ratios. So I have 16.9. You can always create your own ratios. That helps when you're building for specific target devices, like, you know, tablet that has specific resolution or things like that. But for now, I just want to see the 16:9. Okay, so this is what I'm seeing. If I go back to my material, remember, if I want to see the properties for these, I need to be in the inspector. So if I go back to my material, I see I have some capabilities over here. So first of all, I can rotate my skybox. So I'm going to do, I think I like this sun. And then I can affect its exposure. I can make it brighter and less bright. And I can also affect the color. So it's going to have some sort of color on the bright parts. I'm not going to change the color for now. So this is my skybox. Going back to my lighting settings, I want to, as a sun source, I'm going to put the directional light. So I'm gonna grab it and drag it over here, or I can do the normal way, just look for it through the circle. What else? Okay, so over here, I see some options about the base lighting basically of our thing. So I see that the environment is lit by my skybox. I can either select the skybox, or I can select the color, or I can select something else. You see how it changes, like sort of the ambience changes. Over here is the intensity multiplier. So it's how much my environment is going to be lit by the skybox. And then I also have the environment reflections. So right now I have set that my whatever game object, if they are reflective, they're going to reflect the skybox. And there's a resolution for these reflections. Let's take it up to 256. And in order to see how this thing is lit, because it's not lit yet, because we never did that, we want to click this to auto-generate. And this is going to bake things. And this is the actual lighting of our model. So before this step, we weren't actually seeing any global illumination or things like that from our lights, because this wasn't on. So this is how our thing actually looks. And let's go to add some materials to our game objects. I don't care about the player because we're not seeing the player. It's a first-person controller, so that's fine. But I want to change the configuration and the ground. Let's first go to our assembly. So I'm going to right click, I'm going to create a new material, material, I'm going to name it configuration material. And going to the inspector so that I can see it. For this material, I'm going to make it, you can make it whatever color you like. I'm going to make it a little bit orange, I think. And I'm also going to make it very, very reflective. Okay, so I can attach this to this game object by going to my object and drag and drop it to the material. Okay. And now I'm going to create another material for the ground. So I can go over here, right click, create material, ground material. And over here, in the albedo this time, I'm going to add one texture. And I'm going to add this one, the first one of the roughness. So it's processed and processed 2. Let's add the first one and see what happens. So one of them is has more roughness than the other. We're going to see it when we assign it. I'm going to make it very metallic, and I'm going to say that it's taking the smoothness map from the albedo.
Which one we added for the ground?
Over here.
Yeah, which one?
This one.
Oh, okay.
Sorry, it's a weird name. It's downloaded. So you see that already I added some roughness to my material, and it has this sort of shape. I think that if we added the other one, it's more rough. Yeah, I'm gonna use the second one, which is a bit more rough. I'm also going to color this into a nice orangey thing, I think. Okay, and I'm going to assign this to our ground. All right. I think I'm going to make the ground plane a little larger so that it can hide some more of these skybox things. Okay, and also over here in my ground material, let's add some tiling. So let's make it 10 by 10, so it has some more granularity. And let's also add a normal map. So remember how we imported this normal? Again, we need to make an operation over here. We want to change it from default to normal map and click apply, so that Unity will understand to use this as a normal map. And then going back to my material, ground material, I can go to the normal map, click over here and add this. And then I can change how much this normal map is going to affect or not. So let's make it something like that. Okay, I think that looks all right. And finally, this is the moment to start adding the post-processing effects. So
Eliana, just a question. How did you mark the normal map as a normal map so you recognize it?
You go here in textures, and when you click on it, you change the texture type from default to normal map. If you try to add a normal map, and if you try to add something to a materials normal and it's not a normal map, Unity will automatically ask you if you wanted to fix it by default. So you don't have to worry about it too much, but I just wanted to show you the proper way, I guess. So now we're gonna add the post-processing effects. And like I said, it's an external package. So we're gonna go over here in the window and we're gonna click where it says Package Manager. And the Package Manager is going to have a bunch of things. It's going to take a while to load. And I'm just going to come over here in the search and I'm going to search for post-processing. I'm just going to start typing post and already it pops up over here and I'm going to click install. So this is bringing inside the project some extra things that we want to use. Again, it might take a minute to import everything. Okay, it's in there for me. I don't know if it is for you. Is it all good? Should I continue or is it still loading?
I didn't get that step actually, the package manager.
Oh, sorry.
You
So
repeat
the
that
window package manager, and then you type over here in the search post-processing. It's going to pop up this package, and then you click install over here. It should say install.
Okay, got it. Thanks.
Okay, so the post-processing effects require 3 steps in order for us to use them. The first step is we have to create a post-processing profile. So we're going to I'm going to come over here in my main project. I'm going to right click and I'm going to go to create. And I want where is it? Post-processing profile. Sorry, I was behind. So I'm going to create a post-processing profile. Let's name it profile 1. Okay, that is the first step. The second step is I want to go over here in my hierarchy and I want to create an empty game object. Let's place it as 0, 0, 0. Doesn't really make much difference. And we want to add a component, and this component should be called post-process volume. So I'm going to click on that, and I'm going to make sure that I click is global, and then it asks for a profile. So this is where we can drag and drop our newly created profile, or similarly by the circle, just look for it. And the other thing I want to make sure is that this profile is the layer of this thing is the post-processing. Let me also rename this to post-processing so that we know it's a post-processing thing. Okay, so that was the second step, not too hard. And the third step is that we have to go over here to the camera and we also need to add a component here. It's called the post-process layer. So over here in the post-process layer, we want to select from the layers the post-processing. And over here, we want the fast approximate. Sorry. Fast approximate anti-aliasing. I think. Let me just check, double check what I've done over here. Sorry. We want this one, subpixel. Yes. All right. So we're done with the setup, and now we're gonna start adding some of the post-processing effects. So we'll go back to our volume, and you see over here that it says add effect. It takes me to a menu, and the first thing I want to add is called color grading. And I'm opening this drop down, and the mode is the high definition range, and the tone mapping mode, I'm going to turn it to ACES. First thing. The second thing, we're going to come back to this one. This is the first thing that we're setting up. I'm just going to collapse it again. The second effect that we want to add is called bloom. And again, I'm going to open this menu, and I'm going, in order to enable this, I need to click on this square. So I'm going to enable intensity, threshold, and diffusion. So bloom is an effect that is basically taking the bright parts of your image, and it's giving them this sort of soft, blurry burn effect. You're going to see how it looks. I'm going to take the diffusion up, and if I start bumping up the intensity, you see that I'm getting this kind of cinematic light over there in the middle. So this is the magic of our lovely bloom. And I also want to grab my directional light, and I actually want to make it a little more intense as well, so that I start getting a little bit cinematic over here. Maybe I want this to be a little more red, something like that. Okay. What else? Yes. Okay, so the last thing that we're going to add is we're going to add some fog. Before we do that, we want to bake the reflections for this model. So in order to bake anything in Unity, we want to go to the object, in this case, our configuration, and we want to turn it static. So this is how Unity will know that this scheme object is going to be baked. We were already, in the lighting settings, we were already auto-generating the light. So it has, you see that it's baking, it is baked. So now I'm just gonna unclick that. And I'm going to come over here to other settings. I don't know if it's on for you, where it says fog. And I'm going to click on that. And the method that I'm going to use is going to be exponential. Let's go over here. Now if I start adding this density, you're going to see, let's make it a nicer color. Okay, I might have killed it a little bit. Something like that. So now I don't want to be seeing this background necessarily. So I'm gonna go back to my camera, and over here, sorry, 1 minute. Yes, over here in my camera, I want to enable some fog settings. So I want to go where it says rendering path, and I want to make sure that it's set to deferred. And this will enable some fog settings for us. And you see over here in the fog, the deferred fog, it says that it has been enabled and that I am excluding the skybox. If I don't have this clicked, then I actually don't see this in the background anymore. And I'm getting more of this foggy effect. So now I'm going to go back to my fog and actually make it a bit more natural, I guess. And the last thing I want to do is I want to go to my lights and I want to make it maybe a little brighter. And also I want to, yes, maybe see it a little bit over there. It's obviously too bright. So yeah, this is sort of what we've made. So if I play now, I'm in this more of a cinematic thing and I navigate around my artwork. Well, it's not an artwork, but I guess can be perceived as such in this instance. So the rendering things, they take a while to get used to. I'm not gonna lie, I'm not an expert myself. There are a lot of settings and you need to experiment with different things like the intensity of the lights, the color of the lights, all of these post-processing options. Actually in the color grading, maybe we can come to the temperature and, start making it like a bit, frosty, things like that. You can add the fog, not add the fog. I added it because I did not like the contrast between our plane and the HDRI sky. However, we used it to bake the reflection. So this is reflecting actually the sky that we had, which was much nicer than the default skybox. And yeah, that's it for the rendering. Is it all good?
Yeah, looks cool.
So last step would be to build this as an app so that we can play it. And I mean, play it outside of Unity. So we go over here to File, Build Settings, and it's already set up for us. I want to make sure that I have the active scene over here. So it says Add Open Scenes, and I see that the open scene is the Design 1 walkthrough. It's checked, so this is the scene that's going to be built. And then I go over here where it says Build, and it's going to point me to where do you want to build this. Usually I prefer to not build it inside the Unity project because it makes the project heavier. So I'm just going to go over here. I'm going to create a new folder. I'm going to name it Session 1 Build. And you see it asks me to select the folder. So I select this one and it's going to start building the app in a minute. Okay. As you see, we had a lot of rendering, post-processing things, and this is lagging a bit our build, but that's okay. I think it's going to do it. Cool. So now it's taking me to this inside this folder, and basically I have the name of the project as an application. And if I double click, it's going to open this app. It's going to say made with Unity, and then here it is. So everything that we created. And if I want to go outside, I'm going to click Alt Tab because it's a bit annoying and it goes to full screen. We can set this up. I just forgot to do it and I can close it. And that's it for today. Do you have any questions, things? Okay. I just want to let you know a bit of the schedule for what we're going to be making. So I thought it would be nice if we create an app that is to showcase what you're doing in design one. So my idea was that we're gonna create an app. You're gonna start with a menu, and you're gonna have a few different items to see. So we're gonna have a scene that's going to be the component scale, and it's where we're going to be able to basically look at the 3D geometry of your component. We can animate the winding pattern, similar to what we did with Milad inside Unity. I mean, it's not going to be the same script. It's going to be much simpler. Then we can have the global scale, which can showcase the order, the assembly sequence of your configuration. We can have this scene that we created today, which is going to be more of a walkthrough, more of a rendered walkthrough thing. If we have time, which I hope we will, we can create another scene that's going to showcase all your optimization generations. So all the geometries that Wallace generated and the different data that came with them. And yeah, that's about it, I think. What is your opinion?
I think everyone is very excited, no?
Yeah.
Yeah, it sounds good.
Yeah, sounds really nice.
Okay.
This will be something that you can take away
Yeah.
and use it throughout the year and the project, because this is a very good way of presenting a complex design project with all of the capabilities that Unity gives you. So it's a pretty good skill set to have, and also you can utilize and implement it in every single project that you
Exactly.
like to present it, sophisticated.
Yes. And also, I mean, in the future, it's a very valuable skill, like I said, for anyone who wants to do VR and AR and everything, mixed reality. And also, if you get the hang of it and more from the coding side of things, you can create your own simulations for different things,
Yeah.
which is quite powerful.
Eliana,
Yes.
is there a way you can link your model to the Unity so every time you change it, it gets updated?
You mean from Rhino?
Yeah.
Not directly. There are a bunch of tricks. Obviously, there is Rhino inside, but we don't want to go there because that's something that's still in development. And let's just not go there. Let's just let it be. But there are some neat tricks that you can do. For example, you can have your model export an OBJ file, like you can, I don't know, create a component in Grasshopper and have it saved an OBJ file every time you want, and then this can be linked to Unity, somehow. Basically, it's very interesting to figure out these interoperability routes, because I've been doing it a lot, and figure out what is like the correct workflow for whatever you're making this time. And from my experience, it's a good practice to start with this link and how it's going to be updated and how you're going to transfer things from one program to another in the beginning, so that you have this set up and you're good to go.
Yeah. Okay. Thanks.
Great.
Cool.
So we'll
stuff.
see you guys tomorrow again, no?
Yes.
For the second session. And
Yes.
I hope that the fabrication process is going pretty smoothly.
It will be good if you guys update us like yesterday on Teams.
Yeah.
That's really useful.
Yeah.
Yesterday we got all the materials, like the
Yes.
wood for each team.
Yes.
There's Ashwin teams, the wood, they need to be laser cut.
Okay.
And we found bendable wood for Clinton's group. And for the component of our group, we just have the second axe to finish it, and we start adding the screws. So the chiseling work.
Chiseling, huh?
The chiseling work.
Good. Yeah, George was chiseling yesterday.
Yeah,
Good.
we saw documentation of it. Cool. All right then, guys. Yeah, if like just update us on Teams, and yeah, we'll see you in the morning. Yeah.
Also, Clinton's team, you guys had a question. It's half an hour. Let's have a break for half an hour,
Okay.
and then I'll
Yeah.
send a Zoom link in the phase 1 to follow up that thread, and then we can meet. Okay.
Sure.
Okay, sounds good. Yeah.
Cool.
Sounds